So coming back to this categorical SAC4 scale, it used to be in the 1950s what we call the AC4 scale, and then the government agencies in their wisdom decided to add an extra category as well. So basically now, as it stands, S stands for superabundant, so that's 80% cover and above. Abundant is 40 to 79, and you can see going all the way down there. Rare is so 1 or 2 individuals in the entire time you've been surveying is rare. We have not seen as absent because, as I'm sure you're all aware, we can't guarantee there isn't a single organism on the shore, but we're pretty confident it's absent, so we call it not seen. And then we also have not recorded, which is the Professor Hawkins effect, because he just forgot. And he's been driving me mad for 15 years, because I look at his notebooks and I'll be like, well, you've got 6 species here. Oh yeah, I got carried away looking at limpets. And you're like, yeah, but what do we do with this? You know, somebody who didn't understand what you'd done might have thought it was absent. So we have the Hawkins category as well. This is just a small amount of the species here. We've got 78 on the list. We've got macroalgae, we've got barnacles, we've got limpets, we've got top shells, we've got echinoderms, a whole representative range of important species structurally and functionally. We have species of warmer water origin, we have species of colder water origin, and we have invasive species. And whenever we get an alert for a new invasive species, we put it on the list if we consider it might be a threat to the rocky intertidal. And from this data, we've actually been able to show some of the largest range extensions for these species that prefer the warmer waters to the south of Britain, and their leading edges have been changing extremely quickly since the 1980s to date. And just by looking at them, you can see that they come from a wide range of taxa. So it's not just one type of invertebrate or one type of algae, all sorts of different things. And again, they're following these isotherms around the coast as they move north. Unfortunately, for some of our native cold water species that have their southern range limits in the UK, they're starting to retract and we're getting localised extinctions already. My biggest concern at the moment is this absolutely gorgeous tiny limpet, the little tortoiseshell limpet, and it used to be exclusively found in the north of Scotland when I started in the 2000s, and it had moved from here all the way up to here, the southern limit. We didn't find a single one this year when we went back, not a single one in all of our sites. So again, this species looks like it's been severely compromised by the warming temperatures. So if you're a limpet and you need intertidal conditions and you're chased all the way up here, where do you go next? You go extinct. On to the barnacles. Everybody loves barnacles. I hate barnacles. They're the most boring thing on the planet. They don't do anything. They just sit there. We used to count these in the field and it took forever. So I decided that I was going to overrule Hawkins in my second year and decided we'd start to take digital photographs. So we use macro photography. This is our standard quadrat that we use, again, our 5x5. We do 10 of these per shore height randomly. And what we do is we do it in the high and the middle and low shore, so we get 30 photographs per shore. We also tend to take a few more at each shore height because you can guarantee if the weather's been really bad, some of them haven't really focused so well, so we make sure we take a few extra just in case. And we record newly settled cyprids if they're around. They look like tiny little pink orange sausages. Spats, those are juveniles that have undergone metamorphosis but under a year old. And then the adults. We have several species in the UK, as you can see here. You can tell them apart really, really easily. And now we have the barnacle counter, as we call it. And image analysis isn't good enough to be able to tell the difference between species compared to within, because there's so much variation within a barnacle species compared to between. It's not possible. What this does do, though, is allow us to have a database where we can look at shore location, shore height, shore date, put the surveyor in, and then you click on a species, and then when it's the adult phase or the spat, and then you click on the barnacles themselves, and as you can see, these little white dots have actually got the species name in them. That boots that straight out into an Access database, which we can download really quickly, so then we get that to something usable there. And what can we do with this data? Well, this is a barnacle example here. On the left-hand side, we've got some temperature anomalies. So basically, the blue bars show those years where the sea temperatures were cooler than average, the long-term average, and this goes back down here to 1963. And the warm years show where the sea temperatures at this particular location have been warmer than the long-term average. You know, it doesn't take a particularly bright mind to see that it's been warmer than average for a long, long time now. And the lines represent the barnacles. Brian hates me referring to them as warm and cold water barnacles because it's true, it's all dependent on where you are. But I think it's a nice visual aid for these purposes. So the boreal barnacles that prefer the cold temperatures are the blue line, and the warm water Lusitania in red. And again, you can see that when we've had colder events, the colder water species do better. And very quickly, you see that as soon as the climate starts to warm, the warm water barnacles take off in abundance, and unfortunately this is where we start to see these local extinctions coming in again. This is the beauty of these long-term time series. There's no other way you can actually do this accurately. You can model it and hindcast it, but it's only this kind of data that actually shows you what happened. This also shows you that climate change hasn't just uniformly warmed. We see a lot of the times, oh, well, the average rate of warming from the 1960s to the LRI is this. So many people assume that the climate has just monotonically warmed. In the UK, we've had major oscillations. In the 1950s, it was actually quite warm. And then we had a very, very cold extreme winter, 62, 63, and the intertidal froze for several days. That trimmed the range limits back within 3 days, over 200 kilometres. So one extreme event completely changed the shape of them. And then again, we had the 70s, a bit of a cooler period, and then of course climate change kicks off in the 1980s, and we get the warming again. So if you think about this pattern in climate, it's completely lost when you stick a straight line through it and work out of a mean. And what we did with the time series data as well is we looked at what scale of climate is appropriate to track the patterns. This is part of a huge project. They looked at plankton, they looked at pelagic fish, benthic fish, all sorts of different organisms. And we looked at different scales. So the Atlantic multi-decadal oscillation is basically an index for climate, warming and cooling climate across the whole of the Atlantic. And as you can see there, we saw no association with the different species of barnacles at all. When we went to the North Atlantic oscillation, which again I'm sure you've heard about, but basically it's worked out from pressure differences between Iceland and the Azores. This again tells us whether we have warmer, wetter winters or cooler, drier ones. No association at all. The one thing that gave us a brilliant relationship was the sea surface temperature local to Plymouth. So these organisms are not responding to these huge scale changes in climate oscillations. What they respond to is what they're feeling at that location in time. And again, that's really important. We see so many different meta-analyses and global assessments of stuff. That's not what these species are responding to. They're responding to the local environment, and this is very clear with these time series. On to our time searches, my favourite bit. So you grab a bag, you get on your knees, or then when you get to my age, you think, well, maybe students can get on their knees. No, it turns out that this is very sensitive to operator bias. I think I'm the quickest picker. I am definitely the quickest measurer on the planet. I challenge anyone to come up here with a pair of calipers, because I am that hot. It's a non-transferable skill, however. So we bag them up. We've got 5 replicate bags. We then sit there and we measure. We don't just count the abundance, we measure the size of them as well. So we've got a really nice population size, frequency. We can look at juveniles and adults in the population every year as well. And this is, again, for these 2 species, these are 2 of the fastest range extending species in any system on the planet. Again, these little top shells here. And this is the methodology we've been using. The trends that we found, the top one here is through time. So do we see a consistent trend through time, or is it just stochastic environmental variation? These are the last 2. I can't get rid of these error bars. I don't know why I've got error bars of around 0, but they won't go. So these are the only 2 years we had replicated quantitative data from the 80s when they first learned about statistics. And at what was then the northern range limit, there was no species, none of them there. And this is when I started. And I'd like to think this is not just because I got faster and faster. I'm getting older, so probably the other pattern is more likely. But you can see here that every single year through the survey at this one site, there's been more and more and more and more of this individual. So we see an increase across time, across quite a few decades. So this tells us that whatever is causing this is a long-term driver. We then come to the geography here, and this is from the northern range limit population all the way through into France. And I've only put 2 years here. I've put 1986, which again is the turquoise, and this is just the first year when I started in 2002. And look at the difference. Every single population across the upper half of the biogeographical range, hundreds of kilometres, every population has shown a massive increase in abundance. So again, we know that whatever's driving this has got a large spatial extent as well. So this is where we come to the patterns. We've seen these patterns and we think it's probably climate change because it's acting over long time periods and over large spatial scales. I can't put these, I've got hundreds of sites in this area, but I've just tried to put a few on to show you again the trends. So you look at the Northern Range Limit site, this is Wales here. This is where Gray Williams comes from, around about here. Don't want to admit it. So at the range edge you can see the population's increasing, and then they kind of level off at a certain point there, obviously when the population's got saturated. And what we're now seeing is this bit of Wales, we're seeing individuals now start to pop up beyond this existing range limit again. Whereas when you come further down into the range, you do get some kind of stochasticity, but you get, the populations are not increasing as much. Now we also have a second range edge going up the English Channel because we have a temperature gradient here as well. So this is quite a unique example of two different northern range limits moving around, again, responding to this temperature gradient. And you can see a similar thing at the northeastern range limit to the northern range limit, very low abundances, and then this increase again. We've been able to do quite a few things with the SAC4 and the top shell data as well. We've been looking at dynamic species distribution models. And what we're doing here is to try and predict future abundances based on what's been there in the time series in the past, and then we only ran it for two major drivers. So we looked at sea surface temperature and wave fetch, which is a measure of exposure. But the models were able to, for the first time, to work on the categorical data because it's been really difficult to statistically analyse. I hold my hand up and say I didn't do the modelling. This is some really talented people. We had some terrestrial modellers that came and worked with us and said we've used this kind of categorical data, for fields and tree patches and stuff. And then we ran the models using the time series data and predicted where these things would be in the future depending on different combinations of sea surface temperature and exposure. So for the first time, this categorical data has been able to be statistically analysed and modelled, so we're making huge advances here. And it's not just about individual species. Individual species are moving, not all of them. Some of them have really not changed in abundance or other range shifts. But it's also about how these species moving at different rates impact the communities as well. Kelp forests, they're a big concern in the UK because a lot of them prefer colder waters. So we're kind of concerned that many of them may either decrease in size or may be taken over by the warmer water species or invasives. And the big question for me is it community composition of kelp? So is it the species that matter, or is it just that we've still got the same size of kelp forest present? And we went and had a look, and the really interesting thing here is there's a split between the intertidal and subtidal sections. The intertidal kelp populations have shown very little change over the entire time series that I've been working on. The abundance of the cold water kelps has not really reduced. We've seen a slight increase in warm water and invasives, but not very much at all. As soon as you go below the low tide mark, where the temperatures aren't fluctuating as much, almost entirely dominated in the southwest now by these warm water species. And what we think has been happening here is the intertidal fringe, because it gets really cold temperatures in the winter when the tide's out, is killing off the juvenile stages of the warm water species. So we're not seeing any change. Whereas below the water, where the temperature is a lot more stable and it doesn't get too cold, there's been a complete change. So again, it's almost like when Gray put his quadrat above and below the line. It's about looking at the problem and thinking, hang on a minute, just because I'm looking at this little bit here, is that telling me the whole story? And in this case, no, it wasn't. So it was really important that we went and did some diving work and looked at the differences vertically as well.